How you doing today, guys? This is Alex Holmes, your favorite teacher in the whole world. Today we're going to talk about experimental probability of simple events. Now, we already talked about theoretical in the past, and this is not much different. Now, however, theoretical was just a theory. What could have happened of an event? What type of probability, what outcome you could have expected. Now, we're actually doing the experiment. And just like in science, theoretical is what you do before you actually do the experiment. Now we're doing the experiment. The process is gonna be the same thing. The math that we're gonna do is gonna be the same thing. And you can see by looking at this formula. Well, first of all, experimental probability is an estimate of the probability that a particular event will happen. It's called experimental because it's based on data collected from experiments and observations, just like I just talked about. Now the formula, just like on the other one, is gonna be number of times a particular event can happen divided by the total number of trials. So it's just a little different wording than before, but it's still part over total. It's still part over total. Now, we have a few examples right here. It says, number one, Ramon plays outfield, so apparently it's baseball. In the last game, 15 balls were hit in his directions. He caught 12 of them. What is the experimental probability that he will cut the next ball in his direction? And we have a series of questions so that we can come up with the probability estimate. Now, A, what is the number of favorable events? Number of favorable events. That's gonna be the number of times that he caught the ball, right? In this case, he caught the ball how many times? 12. That's gonna be your favorable number. Now, how many times would the hit gone into his direction? 15 times. That's gonna be the total number of trials. 15. So 15 times was the ball going in his direction, and he got it 12 times. What is the experimental probability that random would catch the next ball hit in his direction? So again, probability is gonna be the number of favorable events, which is, what is it? 12 divided by the number of trials, the total number of trials. In this case is, we don't leave the answer like that if we can simplify it. This is not in the simplest form. So in this case, I can divide both of them by 3. So that will be 4/5. Now you can convert this to decimal or percent. The probability that he will get the next ball going in his direction is 4 out of 5. That's it. Just like on theoretical, the process is the same. Number 2, in one inning, Torre pitched 9 strikes and 5 balls. What is the experimental probability that the next pitch she throws is a strike? So again, 9 strikes and 5 balls. And we're looking for the strikes, right? Again, the 2 questions. You're looking for the number of favorable events, which is gonna be what? If you're pitching, what's favorable for you? A strike or a ball? A strike. So how many strikes was that? 9. 9 strikes. What is the total number of trials?
5.
Don't get confused.
Oh.
It was 9 strikes and 5 balls total. In all together, right?
14.
So the number of trials is the addition of those 2, which is
14.
9 plus 5, which is 14. Don't get confused on those guys. You gotta read the whole thing. What is experimental probability? Again, probability, number of favorable events, which is 9 over the total number of trials, which is 14. Can we simplify that fraction? 9 over 14. We cannot, but we can convert to percent or decimal. Again, to divide is top in, bottom out. I'm not gonna do that right now. And the last one. Torre threw 5 pitches for 1 batter, only 1 batter. Kevin, the catcher, caught 4 out of those pitches. What is the experimental probability that Kevin will not catch the next pitch. Will not catch. Again, let's look at the information. Tori threw 5 pitches, and the cutter caught 4 of them. What is the probability that he will not catch the next one? So again, let's find the probability for catching them. Or let's find the probability of how many times he did not catch. How many times he didn't catch? How many times he didn't catch? How many times did he got it? 4. So he caught it 4 times. Not caught it 1. Total times is? Total throws? 5. So what is the probability that he will not catch the next pitch? How many times he didn't get it? 1. How many times did he throw the ball? 1 out of 5. 1/5. Any questions on this, guys? Again, part over total, nothing new. That's it for today's, guys. Have a wonderful day. Thank you.